Taylor Union Watershed. Our advisors are Susie Godekin and Patrick Cradaville. Our researchers are Emily Edelman, Michaela Godekin, Elena Kellen, Caleb Haskell, Ryan Haskell, Caitlin Milan, Macaria Torres, Annie Ramiro, Natalie Ramiro, Aaron Scheffler, Megan Eisman, Caitlin Cruz, Braden Wagner, and Cole Wagner.
These are our sites. Sites 1, 2, and 3 are on Union. Sites 4, 5, 6, and 7 are on Taylor.
Oops, other way around.
Site 1 is on Union, 5 miles south, 5 miles west and 5 miles south of town. Site 2 is on Union, 1 mile west and 4 miles south of town. Site 3 is on Union, a half a mile west and 2 miles south of town. Site 4 is on Taylor, 2 miles west and 1.5 miles north of town. Site 5 is on Taylor, it's by the golf course bridge. Site 6 is below Madison, 1.5 miles east of town. And Site 7 is on Union, 3 miles east and 1/2 mile south of town.
Okay, so for this program we use WQI. We use 9 tests, which are dissolved oxygen, fecal coliform, pH, BOD, temperature, total phosphates, nitrates, turbidity, and total solids. We also do a water discharge test, which is our flow. So when we do this, we get a number out of our colorimeter for most of our tests. And so we'll find it down here and we'll follow it up to where it meets the curve, and then over we'll get our Q value. So if we got a pH of 6, we'd follow it up and we'd say it's about 52, and then we'd put that Q value here in the pH column and multiply it by the weighing factor. You can see the ones with the most weighing factor are the most important to the overall water quality, and then the least have the lowest numbers. And then we add them all up to get our overall WQI, and then they're in these ranges. Most of ours are from medium to good, so from 50 to 90.
Okay, so for the month of May, we had a total of 0.5 inches of rain. And then for June, we had 1.9 inches. For July, we had 0.8 inches. And then for August, we had 0.12 inches of rain.
Alright, dissolved oxygen is the measure of oxygen in the water, and we really would like this number to be higher because we'd like to have more oxygen in our creeks so that we can have more organisms living in them.
So this is our fecal coliform test. We only measure the Escherichia coli in water, although there are other fecal coliforms present. So those are these purple dots. To do this, we put 2 mL of the sample in with a nutrient auger and mix it up and let it sit for a 48-hour incubation period and count the purple dots. So we want all of our fecal coliforms to be under the 235 colonies per 100 mils line, which is this red line right here. We had more under this line than we had in the past, but there still was this major outlier in May, and that's probably because all of the cattle are out at that time of the year, and the feces go into the creek.
pH is a measure of how acidic the water is. Usually you want your test to fall between these two cautionary lines. And as you can see, for our test throughout the summer, we've only had one that's fallen out of the two cautionary lines. So pH was pretty good this summer.
Our 5-day biological oxygen demand is our BOD, and what we do is we take a sample of the water and we put it in a dark area for 5 days, and we measure how much oxygen is in there, we would like the number to be relatively low because we want to make sure that there's no other organisms taking up the oxygen that more important organisms in our creeks need.
Okay, so for temperature, what we do is we test 1 mile above the site and then at the site. And typically when you do that, you would expect the temperature to get warmer. And when it went colder, which are these bars that go below, that would usually indicate an underground spring.
Phosphate measures how much phosphorus is present in the waters. You want some phosphate because that can be good for growth, but you don't want too much because it can cause overgrowth. The cautionary line is at 0.5 parts per million. And as you can see, we hovered right about that line, and we had a few outliers in the month of June. So they were pretty consistent around 0.5 ppm.
Okay, for nitrates, there was no real general trend, and we usually want the nitrates to be underneath the red cautionary line. And we just think that our nitrates are really high this year because we had a lot more rain than we have the other summers, so it makes the runoff from the fields go into the stream. That's why our numbers are so high this summer.
Turbidity is how dirty the water is. For turbidity, there is no cautionary line. But for most of our tests, they stayed in between the 100 and the 50. We had a few outliers, and because in June, the reason why they were kind of all over the place was because we had a lot of rain.
Total solids is the amount of like dirt, twigs, and leaves in the water. And what they normally landed in was in the 40 to 600. There is no cautionary line for this. And the 1st of August was an outlier, and so was the 3rd of June.
Flow is the measure of how much water is actually moving through the creek at a certain time. To measure this, we take the depth of the stream, the width of the stream, and how fast it's moving to calculate the amount of water rushing through it. It all stayed generally low, between 0 and 50, except for August and July at sites 5, 6, and 7. And we think that might be because we had increased rainfall those months.
Water quality index overall just measures how much quality we had. Between these two lines, at 50 and 70, below them would be a bad range. In between them would be a medium range, and above would be a good range. And as you can see, in between, we had most of them in between. So most of our tests fell between a bad and medium range.
Our chemical test conclusions were there's most rain received in July, which received 1.9 inches. Dissolved oxygen was high in June and in July. Fecal coliform numbers were high in May. pH and phosphates were good all summer. Nitrates were above the cautionary line, and more sites were in the medium range.
Macroinvertebrates are the insects that are in the creeks. The macroinvertebrates can give you a little summary of your average quality of water that you have. You can basically do this by catching what kind of macroinvertebrates you have. If you have sensitive macroinvertebrates, you have a cleaner water quality. If you have tolerant, you usually have a mucky or a dirty creek. Somewhat sensitive can live in an okay environment. This is our data sheet that we use to test our macroinvertebrates. We count the number of sensitive bugs, which are the mayflies, the gomphidae, and the beetles, and then we mark how many of the tolerant bugs we have. After that, we divide it by the total number that we caught in that batch and multiply it by 100. By doing this, we'll get a percent of what kind of bugs and how many of them were sensitive. Going to the flip side of this form, we'll put these percentages in this column to see what they fit in between. You'll want a higher score, so you want anything that's in between these numbers for a 6. anything in between these for 3, and anything over here for 0. After that, you'll add them all up, and if you have a total under 8, you have an unacceptable condition. Between 8 and 14, it's partially acceptable, and above 14, it's acceptable. Here's our graph for our macroinvertebrates. This graph shows us what kind of bugs we usually caught in each batch. The 1s were mostly tolerant, the 2s were a mix of sensitive and tolerant, and 3s were mostly sensitive. I think our graph for macroinvertebrates has been getting better each year, and I think this is because each year we've been getting a little bit better at catching these bugs.
Okay, these are some pictures of us at the beginning of the summer doing like our test summary so we can learn how to do the test before we go out into the creek and start testing. These are some pictures of us actually at the sites. Right here is Megan getting the depth of the water for flow, and then there's the width, and then there's some more pictures of us trying to catch the bugs. These 3 pictures right here are of Emily and Annie doing our chemical tests that have to be done at the site, and there's another picture of us trying to catch some bugs. Mrs. Godekin and Emily are working with one of the probes and doing some more tests, and then here's a better picture of us using the probe. And this one right here, Mrs. Godekin is helping Megan get up, and then Megan has a nice watershed selfie. And here are some more pictures of us just doing our width and depth and trying to make our way into the stream and some more bugs. It's kind of a maze to get down there too. Well, we see here some people are just looking down at the people in the creek, and again it's a maze to get down there, and it's kind of muddy, so we got stuck, so we're trying to help each other out. We just had a lot of fun.
Okay, we would like to thank the Lower Elkhorn Natural Resources District and Madison Public Schools. Any questions?